Good afternoon, everyone. Hello, 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 hello. How are you? Are you enjoying your Saturday so far? All that good stuff. Well, it's this time again. We are rounding out and finishing out our lesson for Algebra 1, and we are finishing out our operations Operation Saturdays with division. So the first thing I'm going to touch base on today will be the division part. Then once I finish with the division section, then I will move on to our Algebra 1. Just still going through the key components of this chapter of our lives known as the math of the unknown, also known as Algebra 1. All right, so if you can hear me, please send a heart. Please send a thumbs up. Send something to let me know, hey, you can hear me, you are listening, and that we can get started. Thank you so much. All right, class, let's get started, shall we? So, last operation we are working on is division. Division, of course, is taking a large group and dividing it out into different or taking the group and regrouping it into smaller parts or pieces, such as if I have 20 and I'm dividing it by 4, that means, say for instance, I have 20 stars. As you can see, we have 20 stars. So what I can do with my 20 stars is I am going to break it off into groups of 4. So division simply means taking this 20 and breaking it off into groups of the number that is being divided by. So I need to make 4 equal groups of my number. So we know that 20 divided by 4 is, of course, 5. So that means I need to have 4 equal groups of 5. So I have 1, 2, 3, 4, 5. That's one group. 1, 2, 3, 4, 5. Oops. Undo that. 1, 2, 3, 4, and 5. That's another group. 1, 2, 3, 4, 5. That's another group. And 1, 2, 3, 4, 5 rounds out my final group. So, as you realize, in each group, I have a group of 5. So, 20 divided into 4 equal groups equals 5 in each group. Another example would be still using my 20 divided by 4. Say, for instance, I have a 2 by 2, which would be in total a 4-box flower pot. And in each of my flower pots, I must have the same number I must divide the 20 evenly or equally into my flower pot. Well, best way I can do that is by going through each box and making sure that I am counting as I add into each box. So there's 1, 2, 3, 4. And as you can see, I'm going clockwise. Well, counterclockwise. You can go clockwise. You can go from left to right and then up and down, or you can go up and down, left and right, whichever and however you want to count inside of your box. So I did counterclockwise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, 20 divided by 4. How many flowers do I have in each box? I've taken my 20 and I have divided it evenly in 4 boxes. How many flowers do I have per box? Well, I have 1, 2, 3, 4, 5 flowers per box. So 20 divided by 4 again, that equals 5. So remember, when you are dividing, you can use different tool methods by taking the big numbers and breaking it down into pieces. And this allows you to evenly distribute your pieces, and it allows you to show how you divide by making a box, making a row, or if you have all 20 lined up, such as Skittles or marbles or any of your objects, you can take these objects and then take them and evenly divide them into different sections. So the first number is how many you have. Second number is how many sections you should evenly divide it in. And your answer, of course, is how many in each box or each section do you have. Now, what if I cannot divide my answer evenly? What if instead of 20 divided by 4, I have 21 divided by 4. So now, this can be written in so many ways. Well, we know that evenly 20 divided by 4 gives me 5, right? But you have 1 left over, which most consider is your remainder. So you have 1 flower that hasn't been planted, and it's considered what we call your remainder. Now, your remainder can be written 3 different ways. The first way is, of course, remainder of 1. When you're first learning how to divide, you always put out your remainder. And your remainder helps you build into the next phase, which is fraction. So if you have a remainder of 1, or if you have a remainder at all, what you would do is, if you want it in fraction form, you must first take your remainder and make it your numerator. And then the number that you're dividing by, which is 4, that becomes your denominator. And that's how you go from just writing remainder 1 and then writing your remainder in fraction form. So now we have went from remainder to fraction. Next step is decimal. So how do I go from remainder to fraction and from fraction to decimal? Well, of course, you can divide the old school way, which is taking 4 on the outside, 1 on the inside, and you will divide 4 into 1. Now, I know you're saying, how in the world can I divide 4 into 1? Well, this is how I can divide 4 into 1. First things first is, we know that 4 cannot go into 1, so we're going to put 0 as our first number. And of course, 0 times 4, that gives me 0, minus 1. And so 1 minus 0, that is still 1. Now, when you are trying to go into decimal form, you must, especially if you have no other numbers to go to, you must first add a 0. When you add a 0, you add a decimal. Always remember, once you add that first 0, you must add your decimal. So now, I've added my 0, I've added my decimal. Now, how many times can 10 go, how many times can 4 go into 10 or 10 into 4? Well, we know that 10 can be divided by 4 2 times. Reason why 10 can be divided by 2 times, because you can pull out 2 4s out of 10. So 2 4s out of 10 makes 8. Because 2 times 4, of course, is 8. Once I do that, then I bring down my 2. But I'm still not done, because guess what? I still have a number that I'm dividing by, but I don't want a remainder. I want my decimal. So I add another 0. So basically, when you're dividing a big number by a small number, you're adding zeros to get to either a repeating pattern in your decimal, or a terminated, which means a finite or a end of your decimal. So now 20 will go into 4, or 4 will go into 20 5 times. And so that makes that 0.25. So 5 will go into 4, 5 times 4, that gives me 20. And of course, 20 minus 20, that is 0. So those are no longer, so those are done. And so now your decimal, your fraction has now become a decimal, and now your 1 over 4 is now 0.25. So now your answer is not only 5 remainder of 1 or 5 and 1/4. Now it is 5.25. Now you can also keep in mind that 1/4 means, say for instance, I have a cookie and I split it into 4 pieces, and I eat one piece. That one piece is considered one out of 4 pieces. Therefore, it is a quarter because it takes 4 quarters or 4.25s to make one whole. So with the 0.25, you now can have an answer of, instead of the 5 and remainder 1, now you can have 5 and 1/4. You also can have 5.25. Now, depending on the question, it may ask you either for the remainder, fraction, or mixed number, or decimal. Either way, pay attention to what is being requested of you. But always remember, you can always divide evenly into your numbers by subtracting, taking away, and maneuvering and removing it into another spot. So that is one way of division. Now there's some way of division now that I have seen recently that I would like to share with you. So I call it the hook. Maybe you guys can message me and let me know exactly what it's called. But now division looks something like this. And it allows you to do like place value division. One moment. So with this, you can divide based off of place values. So now, I know that 4 can go into 400 because the 4 inside here, inside of the division problem, that 4 is considered the hundredths place. So how many times can 4 go into 400? Well, 4 can go into 400 100 times. So instead of you writing that at the top, you write that to the side. Once you find that out, you can then take 400 away from the problem, which will leave you with 60. So now, how many times will 4 go into 60? Well, I know that 4 times 15, that gives me 60. But what if I don't know that 4 times 5 gives me 60? But I do remember that 4 times 10, well, that gives me 40, right? So I can then take 4 times 10, that's 40, which again, once I subtract, that leaves me with what? 20. So now, once I have gotten to 20, well, I'm like, hey, I know that 4 times 5, that gives me 20. So this allows me to divide out evenly, right? So then I add up my numbers based off place values, and 0 plus 0 plus 5 is 5, 0 plus 1 is 1, and you bring down your 1, which gives you 115. Now, this is part of the Common Core division mathematics now. And so this helps your child remember place values and how you can divide with your hundreds, your tens, your fives, and your twos, which are great tools to use when you are learning how to divide, right? So when your child is now dividing and you see this hook, know that you are dividing by place value. And if your child understands place values and knowing how to divide by place values, then it'll allow the child to make sure that when they're dividing by that place value, they're getting their numbers to the smallest form. Okay? Any questions? Now, of course, does this work also for when it doesn't divide out evenly? Of course it does. So, say for instance, I have 462, and everything I have done so far has ended in a 2. So now you have a remainder of 2, which you can either write 115 with remainder of 2, or the 115 remainder of 2 can become 115 of 2 over 4, which of course we know that 2 over 4 can be reduced to 1 over 2. Or once you divide that out, that should give you 0.5. Any questions before we start our lesson on today for algebra. Any questions on division? Now remember, division is really simple. You will see it a lot. I mean, a whole lot. It is a very simple task that you will deal with. Know that you can always look for different things that allow you to do division. Now, if you remember, we had talked previously and briefly about keywords in word problems. And so I'm going to share with you the keywords word problems that I have, if you give me one moment. Now, on my screen, you can see keywords and phrases for division. These words are very important because you want to know exactly when do you know when you need to divide. So, first word is each. Pens cost $1 each. How many pens can you buy with $6? So, if you know that if one pen is $1, then how many pens can you get with $6? So you're taking that 6 and you're dividing it into groups of 1. So how many groups of 1, or how many pens can I get with if I take my $6 and I buy all the pens? Well, 6 divided by 1 is 6. So therefore, you will equally, the number of pens equals the number of dollars that you gave. So 6 divided by 1 is, of course, 6. So how many pens did you get? You got 6 pens. Equal and equally. The items were packed equally into 3 bags. How many items were in each bag? So, say for instance, there are 21 items and the items were packed equally into 3 bags. How many items were in each bag? Now, you remember my box that I had with my flowers? Same principle applies. I would draw 3 bags and I would take my 21 items and I will make 21 items evenly distributed within each bag, and I will count up to 21. I would make a circle into each bag until I got to 21. Now, how many items were in each bag? Well, if I took 21 items and I started counting up to 21 and I divided them equally into 3 bags, I know that I should have 7 items in each bag because 21 divided evenly into 3 is 7. So 7 items were in each bag. Next, we have per. You will see per a lot. Per is usually done when you're doing rate, unit rate, proportion, stuff like that. Well, ratio and rate, unit rate specifically. So a car gets 23 miles per gallon. How many gallons will it take to go 470 miles? Well, if you know your car gets 23 miles per gallon, how many gallons would it take for you to get up to 470 miles? So now you will take that 470 and you will divide it evenly into 23. Which, of course, if you divided 470 into 23, you would know that you would have 20 gallons for the 470 miles. Why? Because 20 with a little left over, which would be 20.43. I'm rounding. So it'll take 20.43 gallons to give you 470 miles. And based on the per allows me to know that I'm going to take that 470 and I'm going to evenly distribute it 23 of the 23 miles per gallon because I'm trying to find the gallons. Next, we have if the money was separated into equal shares, how much did each person get? So say, for instance, you have $50 and you decide that you want to divide that $50 into 10 equal shares for 10 equal people. So if you are giving 10 people an equal share of the $50 divided, of course, equally, know that 50 divided by 10, that means 10 people got $5. So take $50, spread it 10 equal ways. 10 equal ways of 50 is 5, because 5 times 10 added back together will give you 50. So if you notice with division, just like subtraction, you're taking something big and you're making it smaller. Take something big, making it smaller. The word a or depending on how you pronounce it. Steak costs $3.69 a pound, meaning 1 pound. So that means how many pounds can you buy for $20? So if $3.69 is 1 pound, then if I divide the $20, it should be 5.42 pounds. Rounding, it would be 5 pounds buy with $20. If we base it on whole pounds, it would be at least 5 pounds for those $20. Now, ratio or ratio of. If the student to teacher ratio is 27-1, how many teachers are there for 756 students? So 27-1, so that means for every one teacher, there's 27 students. So if for every one teacher is 27, how many teachers would it be for 756? So of course, we would take that 756 and we would divide it by 27 because we want to make sure we evenly distribute our students per teacher. So if one teacher handles 27 students, that means each teacher must have 27 students. So I would take my 756 students, I would divide them into groups of 27. How many groups of 27 would I have for 756 students? Well, 756 divided by 27, that is 28. So we have 28 teachers in the school. And for each teacher in that school, the ratio or student would be 27 per each teacher. Therefore, 27 times 28, that gives me back to my 756. Quotient or quotient of, know that when you see that, it's just like seeing the product of. The quotient of 20 and 5, the quotient between 7 and 9, that only simply means you're going to take the first number and it's going to be divided by the second number. Always remember, when you see the quotient of or the quotient period, the first number would be the number that goes on the inside, and the second number will be the number that goes on the outside. Even if the first number is smaller than the second number, the first number still goes on the inside of your division, and the second number goes on the outside of your division, because that's the number you are dividing by. Last but certainly not least is, of course, percent. Percent is a division of 100. Well, percent is a division and multiplication of 100, depending on what you're asking for. But mostly it's based off of dividing by 100. So if you have a population of 250 people, and of those people, those 250 people, you have 100 people that are over 18. That's a lot of people that are under 18, but 100 people over 18. So 100 out of 250, that would be a decimal of 0.4. Now, of course, reducing wise, that would be 40 over 100, which of course would be 40%. Any questions on division? All right, beautiful people, let's get started on our algebra. All right, we were in chapter 6, if I'm not mistaken, where we left off yesterday. And we had learned how to add and subtract inequalities. I think we were on absolute value equations, which, if you remember yesterday with the absolute value equations, because that's where we left off, absolute value equations must equal a positive number. If the absolute value does not equal a positive number when you're solving for it, there is no solution. And of course, if it is positive, then either x will equal 7 or x will equal a negative 7, because the absolute value tells us that I am this many units from the left or this many units from the right of 0. So if I did the absolute value of x plus 1 equals 7, that would be x plus 1 equals 7, or x plus 1 equals a negative 7. And of course, when I solve both of these, I subtract 1 on both sides of my equal sign. And x gives me 6, and x gives me a negative 8. And of course, when I plug both of these numbers in, whether it's negative or positive inside of the absolute value symbol, everything must come out positive. So even if I take the negative 8 and I add 1 to it inside of here, inside of the absolute value, which will be negative 8 plus 1 equals 7, well, that of course gives me the absolute value of negative 7 equals 7. And the absolute value of 7, meaning how many units from the left, is 7. The answer, of course, is still 7. Always remember, your absolute value, whether it's positive or negative, will remain positive. Always. All right, we are moving on to absolute value inequalities. Now, absolute values of inequalities, these will be different. So, say for instance, I have x minus 5 is greater than equal to 7. Now, based on the problem that you have in front of you, this means x minus 5 is greater than equal to 7, or x minus 5 is less than or equal to negative 7. Now, the greater than equal to, you are doing an or statement. Less than or equal to, or the greater than equal to or greater symbol, the greater symbols will give you an or statement. The less than symbols will give you an and statement or compound equality. We'll touch that in a minute. So, add 5 on both sides. Add 5 on both sides. And x comes down. My minus 5 plus 5 cancels, and x is greater than equal to 7 plus 5, which is 12. Or x minus 5 and the plus 5 cancel. I bring down my x, less than or equal to negative 7 plus 5. 7 minus 5 is 2. But since the negative is on the bigger number, it's negative 2. So draw my number line. And of course, yesterday I told you you can do a negative 2, 0, and 12, or you can just do negative 2 and 12, whichever you prefer. Usually if you have a negative number and a positive number, you always want to at least want to put the 0, so that way you can distinguish the left side from the right side. Just a preference. So now, less than equal to negative 2. So I'm going to draw my closed circle because it's equal to. If it was just less than, we would have an open circle. And so once I do that, I would draw to the left from -2, because less than goes to the left, greater than goes to the right. So now I have my 12 I circle and close my circle out. I draw to the right, greater than, less than. That's what it means when it says absolute value inequality for a greater than equal to sign. Now, say for instance, on our next example, we have 4x minus 5, correction, -4x minus 5 plus 3, that is less than 9. Now, if you see with the inequality, since it's less than 9 and it is positive, we can continue with our solution, right? So first thing we must do is get the absolute by itself. By doing so, I am subtracting 3 on both sides. Now remember, the less than is an and statement, meaning you're going to have a compound inequality when you are done. So -3 minus 3, that gives me an absolute value of -4x minus 5 is less than 6. Once I have that done, then either -4x minus 5 is less than 6, and -4x minus 5, move this to the side, is greater than a -6, or -6 is less than -4x minus 5, which is less than 6. If you notice with our signs, they have showing you that, hey, my numbers greater than -6. Also, my number is going to be less than 6. So they're going to meet in the middle. This inequality allows you to, of course, still kill 3 birds with 1 stone, and it allows you to solve for x through a compound inequality. Now, you can still go and solve the answer separately, or make your compound inequality and solve it this way. Now, less thans will cause an and statement, which means you're going to meet in the middle. Greater thans are going to cause separation or statements, meaning one inequality is going one way and another inequality is going the opposite direction. They will never meet. Now, I will add 5 to all sides of the inequalities, just so I can get my -4 by itself, -4x by itself. So now, -6 plus 5, that's -1, less than -4x, less than 6 plus 5, that's 11, right? So now, divide everything by -4. Now remember, when you divide or multiply by a negative, the signs flip. So now you have a 1/4 is greater than x that is greater than a -11/4, or to flip it back into the right perspective, because of course this sentence can be written in the correct order. -11/4 is less than x, which is less than 1/4. Because keep in mind, a negative is less than a positive. Therefore, it must go first in the compound inequality. So if your signs is flipping, where one number becomes, the last number becomes negative and the first number becomes positive, all you have to do is flip it. But once you flip it, you must flip the signs back. So now, with my number line and 0, have a -11/4 to this side, and I have a positive 1/4 on this side. And what I will do is draw open circles because they are not included. And I draw through the middle because those are included. Any questions on solving absolute inequalities? All right, moving on. We are solving linear equations by graphing. Well, solving linear systems by graphing. So system of linear equations simply are, where does these 2 points meet? Where do these 2 lines meet? Where do they cross? How do they touch? So say for instance, I have x plus 2y equals 7. And I have 3x minus 2y, and that equals 5. You would take these two and plot them on a graph. Once you plot them on a graph, you can circle and pinpoint where they are. So you got one graph that's probably going this way because one of them may be negative. And then you have another one that's going this way, and it may be positive. The point where they meet is what you're solving for. So based on the graph that is shown on graphing, you can see if you have the actual graph pulled up, they meet at 3, 2. So now, how do I know that they meet at 3, 2? Well, I can plug my coordinate back into my problem, and if my problem equals up in both of my equations, that is the point where they meet. So, of course, x, y, x plus 2y equals 7 over here. Then you have 3x minus 2y equals 5 over here. X is 3 plus 2 times 2, because y is 2, equals 7. 3 plus 4, because we're still doing orders of operation, that equals 7. 7 equals 7. That checks out. Now, 3 times 3 minus 2 times 2 equals 5 if I can get my screen to stop closing on me. One moment. So now 3 times 3, better, minus 2 times 2. That equals 5. So now 3 times 3, that gives me 9 minus, because a minus 2 times a positive 2 will still give you a minus number. 9 minus 2 times 2, that is 4. And that equals 5. And of course, 5 equals 5. And that checks out my answer. So whenever you are trying to solve an equation, system of equations, by graphing, you first look at the graph, see where they meet, and then you can check your answer by plugging in the coordinate that they met with. Any questions on solving by graphing? You will rarely get to see solving by graphing, but if you do, most likely it's just looking, you're plotting the point and you're plotting your points, you're drawing your graph, and you look at what point that they touch together. But moving right along, we are going to touch on solving equations, solving linear systems by substitution. Substitution is what we have been doing forever since we've been doing Algebra 1. Substitution is simply saying, hey, if A equals B and B equals C, therefore A equals C. So if X equals 7, and I have an equation of X plus Y equals 5, then I must take my take what I know about X, which equaling 7, and I will substitute it for the X in the equation to solve for Y. Same rules apply here. So now with this, you will need to have a substituted number line within the equations, because you have two equations. One of them will have to equal a letter in order for you to substitute and solve for the other one. So what I mean is you have Y equals 3x plus 2, and then you have x plus 2y, and that equals 11. So now we know that y equals what? 3x plus 2. So in the second problem, I can substitute y for 3x plus 2 to solve for x. Then once I find my x, I then can take one of the original problems and find my y, because what you're looking for is where on the graph, where do these two meet? Now, if it's telling you to solve algebraically by substitution, you simply take one of your equation lines, substitute it for one of the letters in the second line, solve. Once you find your answer, plug your answer back into one of the original lines, and then you have your coordinate information. What does that mean, Miss Chris? You're talking Chinese, gibberish, Egyptian, Greek. You're talking in a language that I do not understand. Well, guess what? I am here to help you with that understanding. Now, y equals 3x plus 2. So I'm going to take x plus 2y equals 11 to solve for x. To solve for x, I must first substitute y for 3x plus 2. So x plus 2, well, we know that 2 is being multiplied times y, so I would say 2 times 3x plus 2, and that equals 11. Now, distribute. I'm going to take my 2. I'm going to distribute it to 3x. I'm going to distribute it to my 2. Bring down my x, and 2 times 3x, that's 6x. 2 times 2, that's 4. And it's a plus 4 because that's a positive 2 times a positive 2. And that equals 11. With me so far? Now, once I do that, combine like terms. The combined like terms are x and 6x. That gives me 7x. Now, had x been negative, combining like terms still would have been negative x plus 6x, which would have been 5x. Okay? So then I'm bringing down my plus 4 and my 11. Now I'm going to solve for x. First thing I will do, subtract 4 on both sides. Bring down my 7x. Cross out my plus 4 minus 4, which will give me my equal sign. And 11 minus 4, that is 7. So then divide by 7. And x, once I cross out my 7s, equals 7 divided by 7, which is 1. Now, x equals 1. So first part of my coordinate is x, and my x is 1. So now I found my x, I must now find my y. Now, I can either use the one that I substituted from, or I can use the same equation that I just used to solve for x to find y. Either one of those will give you the exact same answer you need in order to solve. So I'm going to go through the first one. Why not? So we know that x equals 1, so y equals 3 times 1 plus 2. And of course, 3 times 1 is 3 plus 2, and that equals 5. So now, my answer is 1, 5. How do I know that that is my answer? Well, 5 equals 3 times 1 plus 2. 5 equals 3 plus 2, and 5 equals 5. One plus 2 times 5 equals 11. 1 plus 10 equals 11. 11 equals 11. Both answers check out. Therefore, solving my linear system by substitution worked because I was able to substitute successfully, find both my x and my y, and once I found it, was able to check it by plugging both the numbers back into both equations. And since both equations were able to equal out, therefore they meet at 1, 5. Any questions on substitution? All right, moving along. Now, solving linear systems by eliminating. Elimination, all you are doing is either eliminating your x or eliminating your y to solve for either x or y. And then once you solve for x or y, you take that answer, you take the answer of the x or y, plug it back into either one of the problems to give your coordinate answer of where those two lines meet. So now, what if you are solving and you have the right number of variables to eliminate? Meaning, I have 2x plus 3y and that equals 11. Then I have a negative 2x plus 5y, and that equals 13. So now, based on the rules of elimination, you will either subtract or add based on the sign of each term. So now, since 2 is positive, the first 2 is positive, the second 2 is negative, you subtract those 2 by either eliminating or writing 0, whichever you prefer. Now, you have a positive 3y and a positive 5. You add them together to get an 8y. You do not subtract them, you add them together. And that equals, well, I have a positive 11 and a positive 13. I am going to add these together to get 24. Now I have 8y and 24 by itself. I can therefore now solve for y by dividing by 8 on both sides. And of course, y, that equals 3. So now I can take this 3 and plug it into either equation of original equation, and that will give me my x. So I have my y, it's 3. I must now find my x. So I'm going to take the first equation, because I prefer positive numbers, and 2x plus 3. My y is 3, therefore I can substitute for 3. 3 times 3, and that equals 11. Then I have 2x plus 3 times 3, that's 9, and that equals 11. I subtract 9 on both sides. Bring down my 2x. Eliminate my 9s will give me my equal sign, and 11 minus 9, that is 2. Divide by 2 on both sides, and x equals 1. So now my answer is 1, 3. Two times 1 plus 3 times 3 should equal 11. And 2 plus 9 should equal 11. 11 does equal 11, and that checks out. Negative 2 times 1 plus 5 times 3, that should equal 13. So now negative 2 times 1, that's negative 2, plus 5 times 3, that's 15, and that equals 13. And of course, negative 2 from 15, or 15 minus 2, that is 13. And of course, 13 equals 13. That checks out. So your answer is 1, 3. Now, what if you don't have the eliminating numbers to eliminate your x or your y? How do you get those numbers? Well, you can get it by multiplication. So, there is a way of eliminating where you have to do some type of multiplication. Say, for instance, you have 5x plus 2y, and that equals 16. Also have 3x minus 4y, and that equals 20. Now, obviously, 5 plus 3, that's 8. Negative 4 and 2, that's negative 2. 16 and 20, that is 36. But you have not eliminated an x or eliminated a y. So how can I eliminate effectively? Now, if you notice with the x's, you would have to multiply both of them, because the only thing 5 and 3 have in common is 15. So to get 15, I would have to multiply everything to the top by 3 and then multiply everything at the bottom by 5, which could get a lot crazy and a lot messy. And then it's either one of them will have to be negative, the other one has to be positive. Now, we will get into that in a minute, because guess what? You will have those where you have to make the decision of, do I multiply the top by negative and leave the bottom one positive, or multiply the bottom one positive, a bottom one negative, and make the top one positive. Either way, you will eventually have to multiply both of them. This particular multiplication is multiplying one of them. So, since 5 and 3 would cause me to multiply both of them, I would move on to my y. Now, my y allows me to multiply by having only one of them be multiplied. Since you already have a negative 4, and you know that 2 can go into 4, we then can multiply the top line by 2 and a positive 2, so that way I can eliminate my y's. So now, once I have multiplied everything, because everything must be multiplied by 2. You cannot multiply one without multiplying all. Whatever you do to one, you must do to all of them. So 2 times 5x, that gives me my 10x. 2 times 2y, that gives me a plus 2y, plus 4y. Sorry about that. There we go. Sorry about that. So now, (10x) 2 times 2y, that'll give me a positive 4y, and that equals 2 times 16, which is 32, because 6 plus 6 is 12. 10 plus 10 is 20. 20 plus 12, that gives me 32. So now 10 plus 3, that gives me 13x. I eliminate my 4 y's. And of course, equal sign 32 plus 20, that gives me 52. Now, divide 13 on both sides. And for those who play cards, 52 divided by 13 is 4 for all my card players. So now I have found my x. My x is 4. Now you can do this 3 ways because you have 3 equations. I personally recommend you do the original equations, but you also can take the found equation and find your y. But we are going to go back to the original equations, and that's that. So now, which one can I use? Well, I can do the 5x plus 2y equals 16. I can do the 3x minus 4y equals 20. Or I can do the 10x plus 4y equals 32. I can use either one of those 3. And when I use either one of those 3, I should be able to find my correct y. So now, 3 times 4, because I'm using the second original equation, 3 times 4 minus 4y, that equals 20. 3 times 4, that's 12. Minus 4y, and that still equals 20. Now I'm going to subtract 12 on both sides. Because 12 is positive, in order to get rid of it, I must subtract it out. That gives me a negative 4y equals 20 minus 12. Of course, that is 8. Divide by negative 4 on both sides. And you come to find out that your y, it equals 8 divided by negative 4. That is a negative 2. Because positive to negative gives you negative. 8 divided by 4, that is 2. Therefore, my coordinate answer is 4 and negative 2. How can I be sure? Well, 5 times 4 plus 2 times negative 2, that equals 16. 5 times 4, that's 20. 2 times a negative 2, that's a minus 4. And that equals 16. Therefore, 16 equals 16. That checks out. Then, of course, you have 3 times 4 plus, no, not plus, undo that, minus 4 times a negative 2, and that equals 20. 3 times 4, that's 12, minus 4 times a negative 2, that gives me a plus 8, because negative makes positive, plus 4 times 2, 8, equals 20. And of course, 20 equals 20. And those check out. Any questions on the multiplying 1 equation? Now, what if you have two equations and both of those equations require you to multiply both of them? What does that look like? Now, let's try 4x minus 3y equals 8. Then 5x minus 2y, that equals a negative 11. So you remember how I said with one of these equations, you will have to multiply both of them and either make one negative and one positive? This is one of those equations. Now the question is, will you be eliminating your x or will you be eliminating your y? I personally would recommend you always eliminate the one number, eliminate the common factor between the two. So 4 and 5, its common factor is 20. 3 and 2 common factor is 6. Therefore, I would recommend the common factor of 6 for elimination because that will not create as big of numbers as it would with 4 and 5 when you're multiplying to get to the 20. Now, if you like big numbers, go for it. Me personally, I would rather stick with the smaller ones. So now, you have a decision to make. Will the top one be positive and the second one to remain negative, or will the second one become positive and the top one remain negative? Well, me personally, of course, I like things in order. So I'm going to multiply this by negative 2, and I'm going to multiply this by a positive 3. Now, if I multiply everything by a negative 2, negative 2 times 4x, that gives me a negative 8x. Negative 2 times a negative 3y, that gives me a positive 6y. And negative 2 times a positive 8 gives me a negative 16. 3 times 5x, that gives me a positive 15x. 3 times a negative 2, that gives me negative 2y, that gives me a negative 6y. And of course, 3 times a negative 11 gives me a negative 33. Now, combine like terms. 15 minus 8, or negative 8 plus 15, that gives me a positive 7x, because 15 minus 7 is 8. All that good stuff. Then my plus 6y minus 6y, that cancels, which makes me equal negative 16 minus 33. Now, because both of them are negative, I'm going to add them and keep my sign. Therefore, 33 plus 16 is 49. Since it's negative, it's a negative 49. So then I divide by 7 on both sides, and my x equals a negative 7. Now, of course, once I find that, I know that x is a negative 7, because negative to positive negative, 49 and 7, 7. I must now find my y. Of course, you can take the new problems or the original problems, whichever, to solve for your answer. I'm going to choose the top original. So 4 times a negative 7 minus 3y, that equals 8. 4 times a negative 7, that gives me a negative 28. Minus 3y, and that equals 8. Gonna add 28 on both sides. And that allows me to cancel out my 28s, bring down my negative 3y, and that equals 28 plus 8. That should be 36. Divide by negative 3 on both sides. And y equals a negative 12. Positive 36 to 3, 12. So now my x and my y coordinate is negative 7 and negative 12. X, y. And I can check my answer with my negative 7 and my negative 12 by plugging them back in. 4 times negative 7 minus 3 times negative 12, that should give me 8. 4 times a negative 7, that's a negative 28. Negative 3 minus 3 times a negative 12, that is a plus 36, and that equals 8. So 36 minus 28 gives me 8. Therefore, my answer checks out. Five times negative 7 minus 2 times negative 12 move this around and about and fix this so you can see. 5 times a negative 7 minus 2 times a negative 12, and that should give me a negative 11. Five times negative 7, that's negative 35. negative 2 times minus 2 times a negative 12 plus 24. That equals negative 11. And of course, 35 minus 24, that is 11. But since my bigger number is negative, my answer will be negative. Therefore, negative 11 equals negative 11. And my answer still checks out. Now, you will come across no solutions to your equations. What I mean is, if you have 3x plus 2y equals 10, and then you have 3x plus 2y equals 4. To know that it's a no solution, remember you have if A equals B and B equals C, therefore A should equal C, right? Well, in this scenario, B is the 3x plus y. So if 10 equals 3x plus y and 4 equals 3x plus y, that means 10 is supposed to equal 4. That would be a no. 10 cannot equal 4. Therefore, there is no solution to this equation. Now, keep in mind, they have the same slope, but they have different intercepts. Whenever you have something with the same slope and line, but they have different intercepts, that means it will not have a solution. Any questions? All right, beautiful people, we have moved on to chapter 8 of our Algebra 1 book. Now, I will revisit some of these chapters and information in Algebra 2, and I will go in depth into them because they more so pertain to Algebra 2 than they really do to Algebra 1. But whatever you do in Algebra 1, you will also do in Algebra 2. So be ready because it's coming. Apply exponent properties involving products. So now, if you remember, 2 weeks ago, we learned about the law of exponents, where if the numbers are the same base, you can multiply them to, when multiplied together, you can add the exponent. So how did I go from a to the 5th times a to the 9th is a to the 14th? Well, a to the 5th times a to the 9th is a to the 5 plus 9, and that, of course, gives me my a to the 14th. Simple enough, right? Now, say for instance, I have a to the 9th, and it's being divided by a to the 5th. Well, that becomes a to the 4th. Why? Because when you are dividing exponents, a to the 9th over a to the 5th will give you a to the 9 minus 5, and that equals a to the 4th. Now remember, your a to the 9th, a to the 5th, that's still a to the 4th. Remember, your answer in the denominator cannot be 0. 0 will make your answer undefined. So anything number or letter over 0 is undefined, meaning there's no solution. There's no answer for this. Moving right along. Define and use 0 and negative exponent. If you remember last week, anything to the 0 power will always equal 1. Anything to the 0 power will always equal 1. Except 0. 0 to the 0 power, base cannot equal 0. So 0, a to the 0 power is 1. 5 to the 0 power is 1. 1,523 to the 0 power, it is 1. Anything to the first power is itself. So a to the 1 is a. 5 to the 1 is 5. And of course, 1,523 to the 1 is 1,523. So remember these rules. Anything to the 0 power is 1. Anything to the 1 power is itself, by definition. Now, know that if a is to the negative 1, to make all exponents positive, because one question will ask you to make all your exponents positive. To make a negative exponent positive, you must place it under 1. So whenever you're taking your negative exponents and you're making them to a positive, you always place it under 1. Or if you have a fraction, and it's raised to a negative power, you then can flip that and make it whole. Any questions about this? All right, next up we have scientific notation, or what I like to call moving the decimal with single digits or single decimal digits. So, say for instance, you have the number 2 you have the number 2 million and you want it in scientific notation. Scientific notation says I can start my decimal point which usually with a number this big, it starts from the back, and I work my way to the front till I get to a single digit or the ones place. So to take a million placed and turn it into a ones place, I must move my decimal. So I'm going to move my decimal to the left 1, 2, 3, 4, 5, 6 times. And now I have 2, and that's times 10 to the 6th power. Now, when you are trying to do scientific notation, know that you will always have a base of 10 to a certain power. Now, either your power is going to be positive or your power is going to be negative, but know that it will be base 10 or times 10 to a power. Another example would be 0.005. Same rule applied, but this time I'm going to move to the right because my decimal is here and my 5 is over here. So to get my decimal from the 0 and make my 5 the ones place, I will move my decimal 1, 2, 3 times to the right. Now, if I'm moving to the right, my exponent is going to be negative. So, depending on what number you have, that number with scientific notation, the best practice of scientific notation is counting my humps till I get my answer to a single digit or to the ones place. Get my first number to the ones place. So say for instance, I have 2,341. To get that into scientific notation, I would start from the 1 and I would move it 1, 2, 3, place my point, and now my scientific notation is 2.341, and that is times 10 to the 3rd power. Always remember, your scientific notation puts the first number of your values in the ones place. So whether you're moving your decimal to the left and your power is positive, or you move your decimal to the right and your power is negative, know that the main goal is to take your answer and make it the first number, make it into the ones place. Goal is to get it to the ones place. Another example would be 0.0952. Move this 1, 2, because I had to get to the 9. Now I have 9.52, and that is times 10 to the negative 2. Because if I multiply them back out, they will go back into the original spot. Any questions on scientific notation? Moving on, and this is 8.5 and 8.6, which says write and graph the exponential growth or exponential decay of a fraction. Now, here lies two graphs. One of them from left to right is growing, and one of them from left to right is decaying. Never getting zero. Always remember with growth and decay, it never equals or touches zero. So now, if you have whole numbers, those are growths. You will have growths. If you have fractions, you have decays. Whole numbers make growths, fractions make decays. And all you're doing with them are either making it grow. So 2 to the x, which is your growth, where y equals 2 to the x, or y equals 1/2 of x. Know that the whole number, because it's greater than 1, is a growth. A decay lies between 0 and 1. So it's a fraction. So that means it's 1/2, 3/4, 7/8, 11/19. Those are decays. Once it gets past 1, once it gets past the number 1, which is greater than 1, it is a growth. So main thing I want you to remember about growth and decay, whole numbers that are greater than 1 are growths, and fractions, which are between 0 and 1, those are decays. Any questions before we move on to chapter 9? I'm going to take a quick detour because I want you guys to see something right quick. As you can see, I have a handy dandy graphing calculator. What does that look like? Well, with this graphing calculator, I wanted to show you guys what it's like to solve systems of linear inequalities. Now, you will see these when you have a system of inequalities and you have to graph them. Now, say for instance, your inequality is y is greater than equal to -1, which means it goes up. Then you have x, which is greater than -2. Then you have, change the colors here. You have x plus 2y, that is less than equal to 4. This region allows you to see this region where all three meet and touch. That is considered your graph portion, which makes a triangular motion. So you have the region that is to the right of x that equals -2. You have the region going up, which is the y equals -1, or the y is greater than equal to -1. And then, of course, you have our standard form of our equation, which is x plus 2y is less than or equal to 4. And so solving systems of inequality, all you are doing is finding the point where all three of them meet. And as you can see, wait a minute, missing one. As you can see, they meet, all three meet at one point. And that point is 6, -1. Now, or better yet, the answer you're looking for is within this region. So all the points within this triangular region, that is what you're looking for. Those are the ones that are included. So from greater than -2, greater than -1 with -1 included, less than x plus 2y of 4, it will be this region. So all I want you to remember when it comes to graphing the inequalities, know that all you will be doing is shading this portion of the inequalities. Any questions on the inequality section? All right, we are going to move on to chapter 9. Which takes me into my favorite part of algebra, and that is polynomials. So now, polynomials. You have monomials, which have 1 degree term. You have binomials, which have 2 degree terms. And then a polynomial is more than 2 degree terms, which of course, the most popular polynomial is the trinomial. So monomial means 1 term. So that means 10, 3x, 1/2 a to the b squared, or negative 1.8 m to the 5th. So now each have their own degree, and you always line up by the highest degree. So 10 has 0, x has 1, 1/2 b squared, it has 3, because a to the first and b to the second. So I add the exponents together of the 2 bases, and that gives me 3. And my degree of negative 1.8, that is 5. So if I wanted to order these from least to greatest, it would be the 3x, the 1/2 a to the b, a times b squared, and the negative 1.8 m to the fifth. If I want to rearrange them to the greatest, which is how you will always line up your equations, especially when you are adding, subtracting, and multiplying your polynomials, your monomials, and your binomials, which is your one terms, your two terms, and your three terms. When you are multiplying your terms to each other, you will always line up to the highest degree. So that means it would be negative 1.8 m to the fifth. Then it would be 1/2 ab squared then the 3x, then the 10. Now remember these orders because you will see them again when you are adding and subtracting your polynomials. Now, monomial is single term. Binomial are two terms. That means I'm taking one of my terms and I'm adding and subtracting it to another term. That is called a binomial. Bi, B-I, that means two terms. Mono, 1 by 2. Now also remember, a binomial is still a polynomial. Why? Because it's more than one term. More than one term makes it a polynomial. So a polynomial with two terms is a binomial. A polynomial with three terms is a trinomial. The most common polynomial that you will solve, break down, and use is going to be the trinomial. There's even a method called FOIL where you take two binomials and you multiply them together and they should equal a trinomial. But we will get into that momentarily. Now, adding and subtracting polynomials. You have 2x to the third minus 5x to the second, or 5 squared, plus x. You then take that and you add 2x squared plus x to the third, and you subtract it from 1. Now, you are going to combine like terms, which, if you remember, we have been doing since the beginning of our tutoring session. So now, how do I combine like terms? Well, what terms are alike? I have a 2x to the third and I have an x to the third. Both of them are positive and I'm adding it. Therefore, 2x to the third plus x to the third, that gives me a 3x to the third. I have a minus 5x squared and a plus 2x squared. Well, minus 5x squared plus 2x squared, that gives me a minus 3x squared. Those are like terms. Next, I have an x. Well, x does not have a term to be added, so I just bring the plus x down. Same thing goes for the -1. -1 doesn't have a term to add, so therefore I bring it down. And so now I have taken my first polynomial, added it to my second polynomial, combined my like terms, and now my answer is 3x to the third minus 3x squared plus x minus 1. Now you can line them up under each other vertically to get the same answer. So if I do 2x to the third minus 5x squared plus x plus 2x, no, plus x to the third. Now keep in mind, you must line up degree to degree. As you saw, I was getting ready to take my 2x to the third and I was getting ready to add it to my 2x to the second. Cannot do that. If they don't have the same degree, you cannot add them to each other. All you can do is put them side by side. So now 2x to the third plus x to the third, you have minus 5x squared plus 2x squared. You have nothing to put under the x, so that can be either plus 0x squared, or you can just leave that blank, whichever you prefer. And you have a minus 1. Which, of course, you could probably put up there a plus 0 to even everything out. Okay? So now, 2x to the third, x to the third, 3x to the third, minus 5x squared plus 2x squared minus 3x squared, plus x plus 0x plus x plus 0 minus 1 minus 1. Next, we have subtracting them. The only difference is that the signs are going to change in the second term when you're subtracting. This is what I mean. You have 4n squared plus 5 minus negative 2n squared plus 2n minus 4. So everything in the parenthesis next to the negative sign, the signs are going to change. So that means I have a 4n squared plus 5, minus to minus is a plus 2n squared, minus to plus is a minus 2n, minus to minus is a plus 4. Now I can combine like terms and then line them up in order. 4n squared plus 2n squared, 6n squared. Minus 2n is minus 2n. Plus 5 plus 4 gives me a plus 9. Any questions on the adding and subtracting of polynomials? Now, here comes my favorite part, multiplying polynomials. Now, you can multiply a monomial to a polynomial, which would be 2x to the third monomial. And you multiply it to a polynomial, x to the third plus 3x to the second minus 2x plus 5. Now, remember, if you notice, it's a monomial, so I'm distributing my monomial to each term. 2x to the third times x to the third. Well, 2 times 1, that's 2. X to the third times x to the third is going to be x to the 6th, because x to the third times x to the third is x to the 3 plus 3. Exponent rules. Plus 2 times 3, because it's a positive 2 to a positive 3. So 2 times 3, that gives me a positive 6. And x to the third times x to the second, that is x to the 5th. Then I have 2 times a negative 2, that is a negative 4. X to the third, and x to the first, that'll give me x to the 4th. Then, of course, 2 times 5, that's 10. And then I bring along my x to the third. And that's plus, because both of them are positive. Now, how do I multiply my polynomial, which is a binomial, two binomials, to get my answer? You can do this 2 ways. You can either do it by table, or you can do it by FOIL. You can multiply vertically, and you can multiply horizontally. I'm going to give you an example of each one. Now, multiplying polynomials by using a table. Say, for instance, I have x minus 4 and 3x plus 2. The array model says I can take my terms of 3x and 2, and they must be multiplied evenly by x and negative 4. Now, remember when I taught you multiplication, I gave you the array model for when it was just numbers. Now you can do it with polynomials, and this is how. X times 3x will give me 3x squared, because 3 times 1 is 3. X times x is going to be x squared, because x to the 1 is x to the 1 plus 1, which gives me x squared. Now I will take my x and I will multiply it to my 2, and that will give me 2x. Number times a letter, still a number times a letter. Now, you have negative 4 times 3x. That gives me a negative 12x. Negative 4 times 2. That gives me a negative 8. So now, I take my terms and I combine them. So I have 3x squared plus 2x, and you have a minus 12x and a minus 8. So that's 3x squared, 2x minus 10x minus 12x gives me a minus 10x. And then, of course, I have my minus 8. So my two binomials multiplied together gave me a trinomial of 3x squared minus 10x minus 8 when I combine all terms, like terms. Next, we have multiplying vertically. I have b squared plus 6b minus 7, a trinomial, and I'm multiplying to a binomial of 3b minus 4. So vertically, of course, I'm going to multiply it by doing old school way. B squared plus 6b minus 7, and that's times 3b minus 4. Negative 4 times a negative 7 gives me a positive 28. Negative 4 times a positive 6b gives me a negative 7 times a negative 4 gives me a positive 28, so that's plus 28. Negative 4 times a positive 6b, that gives me a negative 24b. And then negative 4 times b squared, that gives me a negative 4b squared. Now, I'm going to take my 3b and I'm going to multiply it to my negative 7, and that gives me a negative 21b. If you're really old school, you know you can take a 0 and you can put it as a placeholder for the place that you didn't multiply. So, negative 21b from 3b times negative 7. Then I have 3b times 6b squared. That gives me a positive or plus 18b squared. And then, of course, 3b times b squared, that gives me 3b to the third. So now 28 and 0, that's plus 28. Negative 24 and negative 21. That gives me a minus 45b, negative 4b squared, and a positive 18b squared. That gives me a positive or plus 14b squared. And what I'm left with is 3b to the third. Multiplying horizontally. Say I have 2x squared plus 5x minus 1 times 4x minus 3. Distributive property says I can take each of the terms in the first one and multiply it to all the terms in the second one. What that would look like would be 2x squared times 4x minus 3 plus 5x times 4x minus 3 minus 1 times 4x minus 3. So when I do that, I end up with distributing through each parenthesis 8x to the third minus 6x squared plus 20x squared minus 15x minus 4x plus 3. Distribute, 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 distribute. And this allows me to further combine my like terms. So now I bring down my 8x to the third minus 6x squared plus 20x squared. That gives me a plus 14x squared minus 15x minus 4x. That gives me a minus 19x. And I bring down my plus 3. Any questions on multiplying vertically or horizontally? All right. Moving on, we have multiply binomials using the FOIL pattern. FOIL. F O I L. This method is best used for when you are multiplying binomials to each other. The F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. And if you notice, it follows the same pattern of the distribute property vertically. And this is what I mean. So you have two x x plus 3 and x plus 4. First means I multiply my first two terms, and that gives me x squared. Outer means I multiply my first term in the first parenthesis and the second term in the second parenthesis. So the first term of the first binomial to the second term of the second binomial is the outer multiplication, and that is plus 4x, because 4 times x is 4x. Then, or better yet, change the colors. That way you can see it. Yeah. Let's make foil colorful, shall we? So this will be O. I will be blue. L will be green. So now, first outer, inner, the second term in my first binomial will be multiplied to the first term of my second binomial. So 3x times 3 times x will give me my plus 3x. Last, of course, indicate you're going to multiply the last terms to each other. So now 3 is going to be multiplied to 4, which will give me a positive 12. Now I will combine like terms, because 4x is like 3x. Therefore, x squared plus 7x plus 12 is my answer. And that is how you do the FOIL method. Now, there are rules to your binomials. If you notice, if it is plus and plus, it will be plus and plus. If it is negative and negative, And this one. If they're both negative, that means my middle term is going to be negative, but my last term is still going to remain positive. So now that's a minus 4x, my 3x, which gives me a minus 7x. So a negative negative will give you a negative positive. That means your middle term is going to be negative. Your last term is going to be positive. Now, here is where this gets fun. Say, for instance, one of them is negative and one of them is positive. Now, say, for instance, your 3 is positive, your 4 is negative. Well, outer, that's a negative 4x. Inner, that is a positive 3x. Negative 4x plus 3x, that gives me, correction. This becomes negative because a negative to a positive makes it negative. So if it's positive, negative, or negative, positive, your last term is going to be negative. The only thing that will change is your inner term. Your inner term with plus, minus, or minus, plus. Either it's going to be negative like this one, which would make this a negative x, because negative 4x plus 3x is a negative x. Or if 3 is negative and 4 is positive, then my middle term becomes positive. Notice when you're dealing with minus plus, the big term determines the middle term, if it's going to be positive or it's going to be negative. So if the bigger term is positive, the middle term is going to be positive. If my middle term is negative, if my bigger term is negative, my middle term will be negative. Any questions on FOIL and the different terms? Last but certainly not least, we are going to cover special products of polynomials and solving for the polynomials. Actually, we'll save solving for polynomials for Algebra 2. And this will be the end of Algebra 1. Because as I said, Algebra 1, Algebra 2, they have the exact same learning methods. It's just some terms are different than others. So now, what I'm going to show you is something that you will see more often than not, and that is when you have two terms and they are exactly the same. X plus 3 times x plus 3 has a formula, and x minus 3 times x minus 3 has a formula. When you have the exact same first binomial multiplied to the exact same second binomial, there's a formula method that allows you to multiply them together, which is called the square of a binomial pattern. What that means is if it's positive, if it is positive, a squared, a plus b squared, then a squared is added to 2 times a and b, which is added to b squared. Same thing if it's negative, you have a minus b squared. A is squared, but instead of it being plus 2b, you have minus 2b, which 2ab, which is 2 times a times b, plus b squared. The first term is a, the second term is b. All you have to do is substitute. So based on the formula for the plus, a would be x squared, so a squared becomes x squared, plus 2 times a, which is x, and 3, which is b, and then you're going to add 3 squared, which gives me x squared plus 6x plus 9. Now this only works if they are exactly the same. Now, the only difference between the top versus the bottom is a minus sign. X squared is still x squared. Negative 2 times x times 3 is a negative 6x plus 3 squared, which is 9. Any questions on that? Last but certainly not least is one of my favorites, which is the difference of squares. Say, for instance, you have x plus 3 and you have x minus 3. Difference of squares, say if I have the exact same terms but opposite signs, such as a plus b times a minus b, therefore a squared is minus of b squared. So based on the rule up top, this is my a, this is my b, plugging into difference of square formula, a squared is a is x, so therefore that's x squared, and b is 3. Therefore, the 3 is being squared. So x squared is minus 9. Reason why they were able to come up with this method is because if you do FOIL on this, you'll have x squared minus 3x, well, plus 3x minus 3x minus 9. These two are the same but opposite signs. Therefore, those become 0, and what you're left with is x squared minus 9. So they said, hey, when you have one term and another term, have one binomial and another binomial with the exact same type of terms, but the same type of terms have different signs, such as plus and minus, you can eliminate the middle, which is what we're used to with a binomial, with multiplying binomial, and it becomes a trinomial, and you turn the difference of squares into a binomial. You take two binomials with opposite signs with the same numbers and letters, multiply them together, you will end up with a binomial of x squared, of the x being squared and the number being squared with a minus sign in the middle. Any question, guys, on what we have learned today? Well, beautiful people, thank you for joining me in Algebra 1, going through the key components of Algebra 1. What does that look like? How does that work? All of that good stuff. If you missed the live and you would like to watch it, once I end it, you can see it on my Facebook page as well as my YouTube page. Rewind, review, and let's finish learning how to do algebra. Algebra 1 is the math of is the beginning of learning about the math of the unknown. And you won't know what it is until you try. So, my name is Miss Chris, and I hope that you guys had a fantastic Saturday. And thank you for tuning in and joining me in this lesson for today. If you have any questions outside of the live, you can inbox me, IM me, or DM me. You also can text me at 205-542-5062, 205-542-5062. All right, guys, we're going to go ahead and end this live. If you have any questions, you guys know how to reach me. If you want to review the videos, they will be available to you as soon as I end the broadcast. They will be on all of my Facebook pages. Know that all questions are important to me because Miss Chris loves to help all those who are in need of help with their mathematical journey. I pray that you have a blessed and prosperous day. Enjoy the day, for it is bright and sunny outside. Even if it's raining, know that there's still light shining inside the rain. You guys have a fantastic day. I'll see you on Monday, 5 p.m. sharp. Please don't be late. And I'll talk to you soon. I'm Miss Chris of Mathematics for You Tutorial Services, LLC, where we are changing mindsets one problem at a time. Have a blessed evening. Good night.